The first thing I need to give you, you might be assigning the attendance form. The first thing you need is a big old warning. This is a workshop on malware. So I am going to beat you over the head with this for a little while. Malware is dangerous. Malware is code that does unintended and bad things to your computer. I'm going to say right now, I'm going to say some things that might seem scary. You might not want to start this machine up that I've sent you. It's configured to be safe. This whole thing has been designed to keep you, your computer, and everyone else safe. But I just want to warn you about playing around with malware in general. So malware is dangerous. It causes damage to your files and your systems. It spies on you and it spies on your system. And it can spread to hurt other people. We're all living in COVID times. We know what it's like to not worry about us getting sick, but to getting other people sick. Malware is very similar to that. There's a reason we call them viruses. So be very careful when you're doing things with malware. It's very important to know what you're doing. Sometimes playing around and clicking on things that you're not sure of that can have consequences, pretty bad consequences when you're using malware. So yeah, don't play with the malware. By that, I sort of mean don't put it on other people's systems to see what happens. This is not a joke. Malware is not a meme. It's not funny. It actually has serious repercussions. Look at me right now. Malware is dangerous. With that, using malware nefariously can get you an Uber Perma InfoSec club ban. Remember that we have a code of ethics. Doing stuff like running malware on people's systems or spreading malware would definitely violate the club code of ethics, and would get you kicked out of the club, not to mention possibly also real-life legal consequences. There are laws out there that deal with using malware and causing damage to computer systems, and people have been charged and put in prison for doing really bad stuff with malware. Finally, seriously, you guys, don't do bad things with malware. That being said, we're having this workshop because understanding malware is really important. It's something that exists out there. It's a big part of information security. Malware is just basically any program that you don't want that does things that you don't want it to do. In the same way that weeds grow in gardens, malware is just programs and code that do dangerous and bad things on computers. In this way, Java is like malware in my life. I just don't want it around because I think it does bad things. But we're talking about code that's actually built to spy on you, to destroy things. So it's really serious stuff. That's my warning to you about malware. We are going to do this for educational purposes because it's important to learn what this is, how things work, in order to understand how to fight against it. And in that way, I want you to think of everything that we're doing here tonight from the perspective of someone who's trying to defend against malware. This is why we're learning about this. When we talk to people outside of the club, when we tell them about the stuff that the club does, some of the feedback we've had is, wow, you guys do a lot of like attacking stuff, like red team and penetration testing. Like you're always attacking machines. Have you ever tried to defend or like focus on defense? This is going to be a workshop where we will do more defense kind of stuff. So I want you to imagine that you're someone trying to defend a computer system or an organization from malware. We're going to do stuff here that will help you defend your systems or your networks from malware. Our learning goals for tonight, we are going to learn safe malware practices. We are going to learn a bunch of malware concepts. We are also going to learn the basics of malware analysis, both static and dynamic analysis. And so we're going to stop here and I'm going to explain what those are. Static analysis will be an analysis of the malware itself. So without actually running the program or the code, what can we learn about it? We know that we have a file, it's not running. What can we figure out about this program just by looking at it without it running? The next kind of analysis, the sort of other side of analysis, is dynamic analysis, which is once the code is running, what does it do? So we're going to look at the things that the code is doing to your computer system and the things that it's trying to communicate and change and move around. Just checking that we are, yeah, I'm seeing a lot of chat come up. Oh, good. Other people hate Java. That's good to hear. So we're also going to learn some basic tools and techniques. There's a bunch of tools that we're going to use. So some of those tools, everyone's favorite, CyberChef. It all comes back to CyberChef. We've used it before, but it's a cool tool, and I'm going to show you some new stuff that CyberChef can do for us. We're going to use a website called Virustotal. It's very commonly used in malware detection and looking up malware. Just a website. It's a big database of malware. PE Studio, which will look at files, provide hashes, Process Hacker, and Process Monitor. Process Monitor is also known as Procmon. Unfortunately, these two programs have very similar names, and we're going to use them side by side. It can be a little confusing about which one we're using. ProcDot, which we're going to use to analyze processes that run on the machine. HXD, which is just a hex viewer for Windows, because we're only using a Windows machine tonight. And then auto runs, which is going to look at how malware and programs gain persistence on a machine, so how it remains on your computer after you restart. Relevant courses for this topic. We always like to do this to connect it to stuff you're doing in school. Computer Science 530, the Information Theory and Security course. It's running right now. So that's one that we're going to talk about some theories of entropy. And then the other one is, the Malware and Viruses course, Computer Science 527. It doesn't seem to be here. That's weird. We should have a Viruses course. We should have Computer Science 527. It should be here. But unfortunately, the professor that's teaching it has decided to stop, and the department isn't offering it anymore. I'm going to shame the department here, because they keep it in the list of courses that the department has, but they're not offering it anymore. The course is effectively dead, and the malware lab that we had has been taken away. We just don't have our malware course anymore, and it's awful, because a lot of us were really hoping to take it in the next year. But shame on the department for getting rid of an information security course without really announcing it, and leaving it on the books and making us hope that it might come back. It's not there. And if anyone remembers, last year I started a petition to bring back Computer Science 527. There's the link for it right there. If you're interested, please go sign that, and we can try to get that course back. I'd really like it. Dr. Aycock is an excellent prof. We hear about him all the time outside of the university. People tell us, like, oh, you need to go talk to Dr. Aycock. He's not teaching that course anymore. And I feel like our whole program and information security at the U of C is just not as good because of it. So bring back Computer Science 527. With that, we will, there's our petition. With that, we're going to start learning about malware. So the first thing I'm going to talk about is the Malware Sandbox. That large file, it was tossed in chat, was a virtual machine, a Windows 7 virtual machine that I configured and set up for you. It has Windows 7, it's a virtual machine. It's isolated from your computer because it's running in VirtualBox. It's a virtual machine, so it's a program running on your computer, but it's isolated from your computer, from both your file system and from a network connection from your computer. I've not set up any network connection from your Malware Sandbox. So that's to help keep you safe. And also all the tools you need are already loaded onto that virtual machine. So yeah, we're going to be using, like I said, Oracle VM, VirtualBox, and it has Windows 7. If you've loaded the machine up, you're going to notice that there's all kinds of "this is not genuine" and a background for Internet Explorer Developer Edition. This is because you can get that for free. I think it's good for about 30 days. But it does the job that we need for having a Windows environment to test and analyze malware. And this is a very simple environment that I've set up. So we're going to look at what some more complex environments look like. So our Malware Sandbox looks like this. You have your computer. We'll represent it here with this box. And on your computer, you've got all kinds of programs. You've got ICQ, Friendster, you've got Netscape, everything that you run day to day to connect with your friends and go on the internet. You also have VirtualBox if you've set it up. I think a lot of you use VirtualBox for your Kali VMs that we use for the club. I think we recommend VirtualBox. It's one of the most common ones that's out there. And so VirtualBox itself will simulate another operating system inside of it, which we'll show with this box. So on that one, I have installed Windows 7, which you've imported. And on that Windows 7 virtual machine, I have put 3 malware samples. Part of what keeps this safe is that those malware samples are in zip files, and those zip files are password protected. So nothing's going to open those without the password. Another program's not going to open up and run those programs. And also, importantly, you're not going to be poking around in there running those programs without me telling you what the password is. What we are going to do is we are going to run that malware on this virtual machine. So instead of Windows 7, it turns into something like this. The good news is, though, that this virus cannot get out of this box because it's not connected in any way to the outside machine. I know that some people have heard of malware that can break out of virtual machines. It does happen. It's sort of, I think it's newer. It's happened in the last couple of years. I did not give you any malware that was that complicated or could do that. That would be insane. But there is also malware that can detect when it's running in a virtual machine like this and just not do the things it normally would to try to stop us from analyzing it. I've given you some pretty straightforward basic malware. The other benefit of the VirtualBox is that we can take a snapshot of it. And the snapshot allows us to revert backwards to a previous state in the machine. So these snapshots are basically just like consider it a picture of a state of the machine. And we're going to take a snapshot now before we've run any of the malware so that we have a picture of the machine in its clean, safe state without the virus. So that we can just go back. Anytime we infect the machine, we can just revert back with the snapshot to the point before the virus was let loose on the machine. And in this way, we can run the sample, we can analyze it, and then we can go back, we can run it and analyze it again and again. This is one of the real benefits of virtual machines is it's really, really quick and safe to just keep running samples and trying different things with them. So that's what we're going to be doing. I said that this was a really simple sandbox. More commonly, if you were to build a malware analysis environment or a malware sandbox on your machine, what you would do is you would actually create 2 virtual machines inside a VirtualBox. You would create one usually with Windows or whichever machine you're going to run the malware on. Then that you would have a second machine, which I'm calling the proxy machine. What you would do is you would tell the Windows machine, the one with the virus on it, that it is connected to the internet, and you would tell it to connect to the proxy machine. The proxy machine would just listen to any internet traffic coming out of the infected machine. And so it would just log all of that information. You can configure it also to send back replies, basically telling the virus, yep, you're connected to the internet, just keep sending stuff. And in this way, you could analyze the internet traffic that viruses are sending. We're not going to be doing that because I didn't want you to have to set up 2 machines. This might be pretty demanding for some of you. I'm not sure what kind of computers you have. I also wasn't confident on everyone being able to do this. So we're not going to do that, which means when we're doing dynamic analysis, when we're running the malware, we are not going to be able to look at the internet traffic. I have some screenshots of what the extra things you would see with the internet traffic. But for now, we're not going to get to see everything that it's sending and receiving. But I'll show you a little bit about what that looks like. OK, so we are now going to take a snapshot. So if you have set up the malware sandbox, if you've imported it, and if anyone hasn't, post something in the chat to let us know. Yeah, we're going to take a snapshot. So the steps to do that, you can watch here if you'd like. It's pretty quick. This is what your start screen should look like when you open up VirtualBox. I have 2 VMs here. So the one that you have is, I believe, is called InfoSec Malware Sandbox. You're going to click on this button over here, these 3 lines with the 3 boxes. And you're going to get a sort of drop down from there. There's details, snapshots, and logs. I want you to click on snapshots. And that will bring you to this screen, which will show you all of the snapshots you have of the machines that are installed. You probably won't have any if you haven't taken any snapshots. There should just be current state. If you click on current state and then click on the take button to take a snapshot, that'll create a snapshot of your machine as it is right now before you've infected it with anything. It'll ask you to give that snapshot a name. I think in this example, I called mine install, but I think in the one we're going to use that I'm actually using, it's called clean state or clean machine. So give it a name. You can give it a description if you want. And then click on OK once you've given it a name. I'm trying to go a little slower here. And then you should see your snapshot listed there. And it's going to show it to you in sort of a tree structure. If you had more than one snapshot, it would show you which snapshots are after others and which ones are continuations of previous states. So it would build a tree if you went backwards and kept changing things. You could jump back and forth in the states of your machine. We're just going to use one start state and our current state. So yes, that's important. Make sure that you do that because we need to be able to go back to the machine before we install the malware. So what malware are we using? There are 3 samples installed on your desktop. There's a folder called samples. In there are 3 zip files, sample 1, 2, and 3. The first one is a .doc file with a macro that runs in it. The second one is a binary file. It would actually be the file that is downloaded by the macro if we had an internet connection. And the third one is a Trojan, and we're going to learn more about what they do and what they actually are. I warn you now, they are all active, and they are all dangerous pieces of code. Antivirus programs would detect these all quite quickly, you'll find out. But what I'm trying to tell you is do not try to copy these onto your own computer. Don't try to get them out of this sandbox. These are all active pieces of malware. They are all going to run and do stuff on this virtual machine that we've set up. So before we get started, a very important start of things or concepts in malware are hashes. Hashes are something that we've probably seen before. If you're in sort of first year computer science, maybe you haven't played with hashes very much, but anyone that's done any cryptography has almost 100% seen hashes. Actually, if you've done cryptography and you haven't seen hashes, you haven't done cryptography, right? But it's used all over the place in computer science. And hashes are just awesome, and they're incredible workhorses. And for those of you who don't know what they are, a little explanation. A hash is a function that turns some sort of input into a fixed output. It's commonly used for strings. So we can feed a regular string. In this case, I love you is fed into this hash function, and it spits out this fixed length string. This is supposed to be, if the hash function is good, this string is going to be unique to the input. So only every input has a unique hash output. And again, one of the key things about this is no matter how big the input is, if it's just the words I love you or it's a whole book of Shakespeare, it'll always hash out to something that's a fixed length. So we can hash strings. We know about that. Another thing is that if we change anything in the input, the slightest thing in the input, the output will be completely different. So if we put I love you, YU instead of YOU, this hash output would be a completely different thing. It would not look anything like a similar input. And that's very important. So the reason we use them in malware is because we can also hash programs. So we're going to feed programs into a hash function, and it's going to spit out a string, a fixed string that should be unique to that program. And again, if you change anything in the program, and I mean if you change 1 bit, so a 1 to a 0 somewhere in the program, then the output of the hash should be something completely different. And you should realize that this is really useful because it means that if we want to know, or if we want to identify malware, we can just hash it and get this string, and this will identify that file pretty uniquely. And we can just take this string and feed it into something to find out more about that malware. For example, we don't have to take a file and dump it into Google and search it. We can just take the hash string and search that and get some information about it. So with that, I want you to go to your desktop on your virtual machine, start it up, and I want you to unzip sample1.zip in that samples folder. And I am going to go and do the same. I told myself I was going to get this started up before we did this workshop, but I didn't. So I'm just booting up my malware environment here. So this is the Windows system starting up. The first time that you start it, you're going to see lots of pop-ups. I can get rid of this. There's going to be stuff telling you that Windows isn't genuine. Just sort of click either the sort of try later or cancel. Probably would have been pretty easy to get an illegitimate version of Windows 7, but I tried to keep it as legitimate as possible. So yeah, it wants you to activate it. So we're going to say ask me later. Windows activation. Okay, tell me about that later. And here you are. You're on your desktop. There's this warning. This is the Internet Explorer Development Edition, so it keeps this background. I tried to change it. I didn't spend a lot of time trying to change it. You should notice down here that it's trying to connect to the internet, and it's saying that it's not connected. If you're doing this right, it should say it's not connected. The samples you have are in here. Someone's got a question. I have the virtual guest edition. Would that be a problem with this machine? No, I don't think it should be. It shouldn't be a problem at all. But yeah, I want you to, the big thing I think you should double check is just down in the bottom corner that your network is not connected. Again, very important that this not be connected to the internet. Malware will try to spread. It wants to connect to the internet to download stuff, and we don't want it to do that. So yeah, on your desktop, sample one, double click to open it. Here's a file. It's a Word file. Drag it to the desktop, and before it unzips it, or in this case, unrars it, it wants a password. So the password is infected. The word infected, I click on OK, and it puts it on the desktop. So I can close both of those. Great. Now our malware is on the desktop. Yes, also, so we're going to be doing lots of steps. Alex says, if anyone falls behind, I can catch you up in our Discord. Alex did this workshop yesterday, so she's familiar with the steps of what we're doing. I'll tell you right now, it might be tricky for you to sort of go back and forth between me explaining, looking at my machine, and trying to do it on yours. If at any point I'm going too fast or you guys think I need to slow down, toss it in the chat and let me know. Tell me right away that, that you need to slow down a little bit. Okay, so we have this file. I'll tell you that this file does bad things. Question was, are people are generally in general or just on Twitch? Discord general channel. I believe people are, sorry, there's breakout rooms down here that we have in our Discord server. They're sort of at the bottom of the list of channels. You can jump down there, and Alex is currently in one of the breakout rooms. Yes, we are not in the CTF server. We're in the club server. And then there's also, I think, a stream chat. Maybe we don't have a chat. Voice channels, yeah, there's a stream chat or the general chat in here that you can ask for help in. So that's just in case you need anything there. And yeah, like I said, if I go too fast, I know I can speak pretty fast. Just tell me to slow down. So the first thing we're going to do is we are not going to open this. This is infected, and it might do bad things, but as long as it's not opened, it's okay. That's the same for all of the samples that we have here. They don't run themselves. You need to open them and run them. The first thing we're going to do is we're going to drag this file over onto PE Studio. So PE Studio is one of the programs we have. If we drag it onto there, it's going to analyze and run that file. And here, PE Studio is now running. You can see some of the things over here say wait. They're just running through the file and getting data on them. And here, the first thing we see, the reason why I explained to you what hashes were we see some hashes. So hashes are used all over the place in malware. They're very important. You can see there's 3 different hashes. Usually MD5 or SHA-1 hashes are used. Other things that it's going to show you are the first hex bytes, the first bytes of the program in hex. And then it shows you its file size, and it shows you the file entropy. So if you remember our intro to reversing workshop, the first hex bytes in a file are important and very interesting. They tell us a lot about what kind of file it is. They're sometimes called magic bytes or the file header. And they identify what kind of file it is. So we can see what kind of bytes these are. These start with D0CF11. And if I wanted to take a look at what this might be, I could go to a website. Because I remember a great site for this, I search Gary Kessler Magic Bytes. And I'll toss this in the chat for you guys. This is a website that has a list of all kinds of file headers. So if you scroll down, it just shows you the bytes that start for different kinds of files. We said that this one starts with D0 space CF space 11. And we found one that has this. This one right here, this looks to be a match for the bytes that start out with our file. E0 A1 B1, E0 A1 B1. Yeah, this is going to be a match. So these are the bytes that start out with our file, and this tells us that this is the standard start for a doc file or a PPS, PPT. Any of these files usually start with this series of bytes. So this is a Microsoft Office Word file, or at least it's legitimately looks like in the data that it's a legitimate Microsoft Office file. So that's good. This is not something pretending to be a Microsoft Office file. It looks to be a genuine Microsoft Office file, so that's good. We can be confident that whatever this is, it's probably the right kind of file. So that's the hex bytes, and that's something you can do with any sort of malware to sort of see if it's masquerading or what it might actually be. Yeah, so now what I want you to do is to take that hash and try to find out more about this piece of malware. I told you that we were going to use virustotal.com, so hint, copy that hash, go to virustotal.com and search it. So I'm going to go back here, I'm going to right-click, copy the value of that MD5 hash, and then go back out to my web page, go to virustotal.com. Virustotal.com is a legitimate site, not a site that's going to give you viruses. And this is what it looks like. Doesn't look like a huge site. We could copy the file and submit it here. We don't want to be pulling the file out of our sandbox, like I said. So we're going to go over here to search, and it says you can search URLs, IP addresses, domains, or file hashes. Toss your file hash in there and click enter. And here you are. You get a whole bunch of information about that hash that you tossed in. It's telling you some information. I'm going to give you 2 minutes to just poke around this website and sort of see what you can find. I could explain it all to you, but it's more fun to sort of explore for a little bit. So 2 minutes on the clock. Go ahead and see what you can find. And feel free to toss anything in the chat that you find that you think is interesting. Okay, I'm going to say that's been about 2 minutes. I know it's quick. The point of this isn't to find anything in particular. No one's tossed anything in the chat. But let me just sort of show you exactly what's going on in here. So this is the Virustotal website. This is what a standard entry in Virustotal looks like. It's currently telling you that 39 engines detected this file. So these are 39 antivirus programs or systems that have detected it. And then it's showing you other ones that don't detect it. It will also show you the size. It tells you when it was submitted. Shows you it's a doc file. Interestingly, it's tagged with doc, hide app, macros, and obfuscated. Those are going to be clues to stuff we're going to look at later. Some details about it. A lot of information here. There's our MD5 and SHA-1 hashes. So our hashes are here. Again, hashes are really important because it tells us a lot about the file. Tells us it's a Microsoft Office file. Again, the size. Interesting, it talks about its creation. So the creation time of this file was January 16th of 2020. So it's just over a year old. And it was submitted on January 17th. Looks like, yeah, it wasn't even a day. It was about 5 or 6 hours from its creation time to when it was submitted on here. Interestingly, it also shows you some other names of this file. So that's good. Remember, you're thinking like someone who's trying to defend a network. You've got some other names for it. Relations. So it'll tell you about some of the URLs it tries to contact. Gives you a graph of some of the things that it does. So it's sort of an activity graph. And then behavior, it sends HTTP requests out. Here are some of the DNS resolutions that it does. So when it's trying to connect to IP addresses or websites, these are some of the things that it tries to resolve. It then shows you all kinds of information down here. We're going to go into more of those later. Community is an interesting thing. People will submit their own information or analysis information here. I went to the first one here, said something about VMware full analysis. I went there, and here's another website that scores and tells information about this file. So yeah, this is Virustotal. It's a really important site in malware. It's very common to go on this site, search things, and just start grabbing information. So from here, we've learned a few clues about our file and some information about it. So from here, we're going to learn about a malware concept called packing. Packing is a very important concept in malware. It's one of the things that makes malware really difficult to handle and deal with. So what is packing? Packing is just a way to hide the code. Packing is basically obfuscating or encrypting the code. So imagine you write a program. We know from reverse engineering that you could just take that program and put it in something like Ghidra, or Cutter was the one that we used, and start reversing it and decompiling it. But what if we wanted to make that more difficult? And not only for malware, but what if we were a company that came out with a computer game and we didn't just want a bunch of gamers reading the source code and figuring out how to cheat and change the source code? Packing is used for legitimate reasons as well. So what packing does is it takes the code and it will either obfuscate it, so change things around in it, or alternate letters, numbers, upper and lower case, anything to change it to make it more difficult to read. And sometimes it will just straight up encrypt the code. So it'll use cryptography to straight up just scramble what's inside of it. The important thing to note, though, is that, say this is the original code, this is the original executable code, you run it through a packing algorithm, and this is the new program that comes out. So it has a new PE header, so that was those bytes that we saw at the beginning of our file. It might have new bytes. Inside that file is the packed executable. So this is the original. This is the packed version. It's been changed around in all kinds of ways. And then down at the bottom of this picture is the unpacker. So that's the instructions for how to change this packed executable back into the original code and then run that, and then it would run that original code. And there's multiple ways of packing code. So there is single layer packing, which just uses some sort of algorithm. P here is going to be the code. So a single algorithm is run on the code to pack it once. so that's malware that's been packed once. There's repacking algorithms. So you run the same packing algorithm multiple times. So you pack the code. So you get a packed algorithm or a packed executable, and then you pack that one again. So you just run it through multiple times. And it's 2 or more times. So it creates more obfuscation, or like it makes it more difficult to read. And then, of course, there's multi-layer packing, where you use 2 different packers. So you pack it once with one packer, and then you pack it again with a second one. So that makes it more difficult to read. And this is one way that we can hide the code. Why would you do this? Well, you would hide it from antivirus programs. So antivirus programs just want to read the straight up code. There's things that they are going to look for that they know are signs of malware. If they can't just read the code, if they can't just read the code, then they can't detect malware as easily. So packed code can't be read directly. And remember, we use hashes a lot. Antivirus programs also use hashes of code. If the code is packed or packed again, if it gets packed multiple times, remember its hash is going to keep changing. And if your antivirus program doesn't have the hash of that code, then it's not going to recognize it as malware. It also hides it from reverse engineers and enterprising University of Calgary undergrads, or wherever it is you're coming from. You can't simply decompile it and read the code. We need to do a bunch of work, or we need to try to use a packer to reverse it. So how do we figure out if it's packed is the big question. And the answer is entropy. Remember I told you that the information theory and security course was going to be handy? Well, entropy is the way that we measure packing. So for all of you mathematically minded people out there, we use Shannon's formula. Here it is down here. Entropy is used in a lot of cryptography and information theory. It's really important. That's the calculation that is used to figure out what the entropy of code is. It works on measuring usually bits, so zeros and ones in the program. It was invented by this man, Claude Shannon, one of the titans of computer science in the 20th century. Here he is, looking like he's just created all kinds of information theory and is the sort of godfather of cryptography and information theory in the 20th century. He could also be a Bond villain in this image. Claude Shannon is a very interesting person. Not only did he do all kinds of stuff for cryptography and information theory, he was also an inventor. I read that he invented a flame-throwing trumpet, so a trumpet that would shoot flames out of it. He was a really interesting character. Go read more about him if you'd like. But that's Shannon's theory. So I'm going to try to talk about entropy a little more in general. I'm going to use this analogy here. So we have 2 pictures. One of them is a bunch of puzzle pieces, and the other one is broken glass. So let's imagine that broken glass is all from one piece of glass. This is all one puzzle. The puzzle pieces have lower entropy, and the glass has high entropy. So what is entropy? Entropy is just how predictable or how much of if you can find patterns in the information. So with the puzzle pieces are predictable. We look at any one of those and we recognize that they're a puzzle piece. We know how to use them and put them together. We know that there's a pattern in the way that these puzzle pieces are created. If you look at the glass, you don't know if that's one piece of glass or if that's multiple pieces of glass that were broken all up together. It's very unpredictable. The shapes are all very different from each other, and there's a lot of randomness in it. So we say that has high entropy, and the puzzle pieces have, we'll say, lower entropy. So think of it like that: predictability and following patterns. Entropy is measured usually on a scale of 1 to 8. Just to give you an idea, English on this scale usually falls in sort of the 4 to 5 category. Obfuscated code, the kind that we're going to see, so code where they just switch up, say like all the L's turn into 1s, all the A's turn into @ signs, stuff like that. Obfuscated code is about a 6 on the entropy scale, and encrypted code is usually somewhere in the 7 to 8 range. So stuff that's just cryptography that's run on it. And you might say, like, what does entropy mean in terms of English? An example would be that whenever you find a Q in English, you almost always know that the Q is going to be followed by a U. And this makes English pretty predictable. So you know that Qs are probably going to be followed by Us. This gives a sort of pattern, and it gives some predictability to English. So that's why it's a little lower down on the scale. So you're going to notice in PE Studio, this is all important because it tells you what the entropy of this code is. And the entropy of this code shows at a 6.811. I believe that's what it should be for everyone. And that means, what does that mean? Is the code packed? Is it obfuscated? Is it encrypted? It would be really nice if we had an audience, but yes, it means that the code is packed. It means that it's very likely obfuscated. It might even be encrypted. So we're going to find out a little more about that. Some other stuff that we're going to see in here, indicators, if you go to that just underneath, PE Studio is going to tell you some things that it finds a little weird about this program. It says that the file references here a string with a suspicious size. So there's a string somewhere in this. File references strings that are tagged as blacklist. So there's stuff inside this that it thinks are blacklisted and shouldn't be there. And then it's finding other things that it thinks are hints. But there's 2 strings with a suspicious size. The size is 5,265 bytes. So let's remember that. The next thing here is Virustotal. It says it's offline. Remember, that's because we're not connected to the internet on our VM. That's really important. But it would connect to Virustotal and give you some Virustotal information if we were connected. The other thing we have is strings. So we know in Linux, when we do forensics and reverse engineering, strings are always really important. They tell us a lot of stuff. One of the first things we like to do on unknown files is to just strings them and see what's in there. So we can see there's a lot of strings in this file, a whole lot of stuff. We don't want to go through all of this. Let's organize the strings by size. So click on this size column here, and we'll organize it by the biggest one. So the 2 biggest ones are 5,265. These are the strings that PE Studio said look suspicious. And if you look up them up here, they're just a bunch of letters and numbers, and they seem to all be separated by 3 slashes. This could be our obfuscated or encrypted code. Maybe it's separating it up. Maybe that's code somehow. We could go further down. We would want to look for maybe websites or IP addresses or interesting function names that are in here. Remember, this is right now what we're doing is static analysis. We're not running the code. We're just reading about it and trying to find out information about it without running it. So remember, you're trying to defend a network, and you've got this file that's been found, and you're trying to learn information about it. So you could go through here and try to see if there's anything interesting. You can look, and you can see actually in places. I just found one. Here's a string that it found, and PE Studio is saying that it thinks that this is base 64. So we could click on hint to organize by hints. In here, it's telling you information about some of the strings that it's found. So some stuff about Microsoft Office, create, setl, print, those are utilities. There's some interesting file names over here. So maybe those file names are things that we should be looking into. And then there's a couple of base 64. So that's some of what PE Studio does. We're going to get out of PE Studio now. We've done a little bit of static analysis to try to see what this file does. We're satisfied that it's a document. We're pretty satisfied that it's probably malware because Virustotal had a big entry on it. And the entropy means that it's packed. So it would be really difficult to reverse engineer. All right, from here, we're going to start analyzing our file. So let me just see if there's any slides that I need to show you first. Okay, another static analysis we can do. This is a Linux program, so I just want to show this to you. OLE VBA. So this file, it analyzes VBA macros. This file has a macro in it, meaning it has some sort of code in the Microsoft file that it wants to run when it opens the file. This thing would analyze it, and it would tell us this interesting information about the file. Interestingly, it tells us that there's something that is runs when Word or Publisher document is open. So there's something that's going to be run when the file is open. Show window, it may attempt to hide the application, so it might be hiding something. It may attempt to obfuscate specific strings. So these next 3 are all going to tell us that there's things in here to obfuscate strings in the code. So something about this program is trying to be hid. And the last thing says base 64 strings are encoded or detected in the program. So again, that's something that we already sort of saw, but that's another hint. So we're going to go back to our virtual machine. And now we're going to fire up 2 more of our tools. So we're going to fire up Process Hacker, and we're going to run it in administrator mode. So right-click on Process Hacker 2, then go up to Run as Administrator. Yes, we want to give it permission to run as administrator. And then Procmon, the one that's right beside it down here, also known as Process Monitor, run that one. And it opens up over here. You should see a screen that looks like this. So the first thing it's going to ask you is to filter what it's looking at. I'm going to tell you right now, the first thing listed has a green check mark next to it. Uncheck that box on this first entry. So we're not going to filter out, we're not going to use the first filter. And now click on OK. And you should start seeing this box just filling up with all kinds of things. So Process Monitor is a program that monitors everything that's going on in your computer. So it's monitoring everything, all the processes that are running in the background, and it's monitoring everything they're doing and accessing. So I'm going to maximize this. You can see down in the bottom corner down here, it's telling you how many things, how many events. So every process that's running generates an event. Everything it does generates an event, and it's tracking all of these events. So there's currently 65,000 events that it's tracking. That's interesting. It just goes to tell you that there's a lot of stuff just happening in the background on a Windows machine, just as it's sitting there and idling. The other program, Process Hacker, over here, looks a lot like your task manager, and it's very similar to that. This is just showing you everything that's running on your computer right now, sort of in the background. So I'm going to move these 2 things over. Again, I'm going to have Process Hacker on the left, Process Monitor on the right. Let's go ahead and open up our Word document. So the one that we unzipped, our malicious file, let's go ahead and open it. So we get this box here saying the command cannot be performed. It wants us to activate Microsoft Word. We're going to click cancel. I got a demo, sort of a demo version. So here's our file. It's loaded up. Remember, this file was created last year, so it uses Office 365. And it tells us that the document is only available for desktop or laptop versions of Microsoft Office Word. To open the document, follow these steps. So click Enable Editing button on the yellow bar above. And once you have enabled editing, please click Enable Content button. In the newer versions of Microsoft Office, those are the things that would pop up. You've probably seen them. You may have seen them before. Office, almost by default, does not like to run macros, these things that are trying to run, because they are prime delivery tools for malware. It's very common for malware to start being delivered by Microsoft Office because people will just click around to get the file open. We're going to click around now to get the file open. So up here, you see a security warning. It says macros have been disabled. That would be good because we don't want it to run malicious code, but we actually want to run this malicious code. So we're going to click Options. We get a security alert. It tries to tell us macros are bad. They contain viruses. Down here, it says, help protect me from unknown content recommended. And then right here, we want to enable this content. So click Enable this content, and then click on OK. And I want you to go back to Process Hacker and Procmon as fast as possible. So click OK to run it, minimize this, and scroll down in Process Hacker, and you'll see processes running. We're going to let things run a little bit. You should be at this step. Again, let me know if you're having any problems in the chat. Great. So we've just run some macros in a Microsoft Word document, and it's now running in the background. I can tell you, if you've run it now, you should be pretty good. You should have been able to track everything that's going on. Let me just see. Where is my process? I think it should be good. I'm not seeing what I thought I would see here. Anyway, this should be running. Okay, so you're tracking all of the, your process monitor is tracking everything that's happening in the background. Process hacker over here running, checking all of your processes. We have run this file. It has done what it's going to do. We're going to close it. Over here in the process monitor, I want you to click File and then click on Capture Events. So we're going to stop capturing events in Process Monitor. Right now it's been logging, so we're going to stop. You should see the numbers down on the bottom left, stop counting up. And so we're going to try to see, this is now in the dynamic analysis part of our analysis. So we've just run the program and we're trying to capture what it is that it's doing while it's running. Up at the top in your toolbar up here, one of these things says Show Process Tree. We're going to click that, and it's going to show us everything about the processes that we're running during our capture. Ah, good. It did do it, I think. Yeah, so I'm going to give you about a minute. Just look through this, see if there's anything interesting that you find, and see if anything stands out to you. I'm going to tell you right now what you're looking at. So I'm going to make this window a little bigger. Over on the left, these are all the processes that were running while we were doing our capture. This green bar over here is interesting to look at. This is the lifetime of that process. So from when we started to when we stopped the capture, this is how long those things were running in there. As you can see, some of them started and stopped partway while this program was running. Anything over here that's kind of grayed out is something that did not, it was not still running when we finished the capture. So you can see the lifetime bar over here doesn't make it to the end on all of the grayed out things. And then there's all kinds of other information that's around here. So I want you to just poke around. You can click on these. You get information about them down at the bottom. See if there's anything that was run that you can notice or that you notice that might not have been good. Give you 1 minute. And toss it in chat if you find anything that you find suspicious. All right, the about a minute is up. One person tossed something in chat. Sorry, we had some questions as well. What do the color in process? Do the colors in Process Hacker mean anything? Yes, of course they do. And the joke, Abner. So the question is probably, what do they mean? I believe they refer to sort of how much memory and CPU each of the processes is using up. I think they flash red when they get killed. I believe that's what they're up to. Somebody says the sshd.exe seems ominous. Yeah, that one is something to be a little bit concerned about. SSH is something that we know can be used to connect to a machine. DLLhost.exe was another guess. That could be it. It's not the one that I'm looking for, but that is, I think that's part of what's happening with this. But someone actually tossed it in there. They said a PowerShell command was run. And so that was B-shape. Someone else said, PowerShell, why did you run? Yes, that's the thing that should be the most alarming. So if we scroll down to the very bottom down here, we see that PowerShell was run. It was run for what looks like a very short time. Do you remember seeing PowerShell run at all when you opened this doc file? The answer should be no, you didn't. If PowerShell was run, why didn't you see it? Well, if you click on it, like I said, you can see some information about it. And down here, we see it was PowerShell, where it was run from, and the command that was used to run it. So the command was PowerShell, and then TACW hidden. So that is going to make sure that no window is actually run when the command runs. And that's why we didn't see PowerShell. So it was run in the background. It was run in sort of a hidden mode. Then has TAC-EN, which I believe is encrypt. And then there's this big, long argument after it here. What is that? Does anyone recognize that? What does it look like? Toss it in chat if you find out, but I'm going to keep going in a second because we need to keep moving. We've got a bunch of stuff to do. The answer is, we were given clues earlier about this thing being found in the code, and the answer is it's base 64. If you look at this, if you're familiar with base 64, it kind of looks like this. So what we're going to do is we're going to copy this. We're going to select it all and copy it. For some reason, PowerShell was run with this big, long argument. Why would you run PowerShell with this big, long argument? Well, it's base 64. And what do we do with base 64? What do we toss it into? That's right. Everyone's favorite tool, CyberChef. The Cyber Swiss Army knife. So we're going to toss our input into CyberChef. We want from base 64. And good, we get it translated into this, whatever this is. So I could give you time to try to work on this. I'm going to just show you how I went about, or how I learned to go about doing this. If you look, there is stuff in there. You can see words. They're separated by dots. But I see web client here. I see COM. I see Fire Labo, 911concept.com. Yeah, there's code in here. We can clean this up though. So if I search remove, I'm going to select remove null bytes from the list of operations over here. So those dots are just null bytes. And when I do that, yeah, we're starting to get, here we go. HTTP aeonschools.com, beach.org. So there's stuff in there. You definitely see a website. Abner's got it. There's definitely a website in there. Let's try to pull those websites out. So let's try to use regular expressions. And this is where I said I was going to show you stuff that CyberChef could do. So the next thing we're going to use for our recipe is a regular expression. Then it says built-in regexes. We're going to go click on this, scroll down to URL. And it finds those URLs. And I think there was a way to... nope. So it's just finding the URLs, and then we're going to use another one. There's no reason you would search this, but I'm going to search defang, but I think I could search URL and it would come up as well. Yep, defang URL. Where did it go? Nope, I want you to go down. Here we go. This is the problem. In our regular expression, instead of highlight matches, we want list matches. So we've listed those matches. Here we go. I took out the defang URL. So we've listed all those matches. What do we notice next? They seem to be separated by a star. So we can search for replace. We're going to find and replace. We're going to find star and replace it with a new line. No, this is not it. Sorry, not replace. I think it's split. Yeah, we want split again. Split, we're going to use star, and then we're going to replace it with the new line. Yep, there we go. That's the way it goes. There we go. Sweet, sweet websites. whatever this was that PowerShell ran, there were a bunch of websites listed in it, and we now have a bunch of websites. And remember, we're trying to defend our system from this. So now we know that it was doing something with these websites. If we were trying to defend our system or a network, we would want to take these and toss them in to our firewall. We would want to search all of our logs, and we would want to see, did anyone in our system try to connect to these websites? If they did, we want to try to block all of these websites probably right away. These are probably not good things that are being run in the background. So there we go. We've got some intelligence. We've got some stuff to help keep us safe. I'm going to remove those last two things. So we're going to go back to this code. I'm going to copy this code out because there's stuff going on in here. Actually, we can see there's sort of equal statements. And it looks like it's assigning variable names. We can also see semicolons in there. So I'm going to run split again. And we're going to split on the semicolon to get this piece of code, to get this. And this looks way more like code now. So let's copy all of this out. I'm going to copy all that code out, and I'm going to toss it into... you can toss it into sort of any text editor you want. I actually have the one open from yesterday when we tested this. I'm going to use Visual Studio. VS Code. And there we go. I paste this in. Now I could start to try to deobfuscate this. I could start to try to figure out what it does. The way you would do this is you would highlight pieces of it to see if it shows up anywhere else in the code. So it looks like there's a variable name here. So something equals this, but when I highlight it, it doesn't show up anywhere else in the code. So it's probably not important. I'm going to delete it. Next thing, something equals 267. I highlight the something, and it shows up somewhere else in code. Okay, so this is just some sort of string that equals 267. So I'm just going to use find and replace. We're going to replace that with 267. So replace all. So 267 equals 267. And then down here we see 267 plus .exe. So there's quotes. This is probably a string. So this is equal to sort of 267.exe. Okay, so second line, nothing, doesn't show up again, get rid of it. Next line, so the 267.exe, before that is a slash, and then before that is env user profile. So that's probably the username of the person using the computer. So there's something about your user profile slash 267.exe. So this is a file that's maybe moving in. Back here is the variable name. That shows up in multiple places. All right, so we'll find and replace that with, we'll call it file name. We'll replace it all. Don't use just the replace, use the replace all button. So we'll replace those all with file name. Next line, yep, doesn't show up anywhere, delete that. And this is the way that we would try to figure out what this does. So I'm just going to go ahead. I see the word new here, new plus dash plus object. So this is creating a new object, and then net web client. This is in weird upper and lowercase. So some sort of new object with a web client is being created. Does this show up in the code? It does. So let's find and replace that with, let's call it web connection. Next line. Next line is all those URLs that we saw. So does that variable show up again? It does. So we're going to find and replace that. We're just going to call that URLs. We know that those play some part in this. Next line. I know this might be hard to do at home if you're just following along. Next line didn't show up. So we see for each, and then this thing shows up. So for each thing in URLs, we're going to call that thing a web address. Yeah, let's call it a web address. Or sorry, just address. So for each address in URLs, it says try web connection dot, and then this is weird looking. It's download file. So it says for each address in URLs, try web connection dot download file. address and file name. So it's trying to download the file name from those web addresses in the URLs. And then it's doing nothing here, so we're going to get rid of that line. Might be more obfuscation. Then we have an if statement. If get plus item file name dot length, dot length dash ge. So that's a greater or equal to. So it's checking to see if the item that it's getting is its length is greater than 25,859. And then it runs diagnostics.process start. I just deleted the wrong character there. Start file name. And then there's some stuff here. This stuff doesn't show up again. This stuff doesn't show up. We see catch down here, so there's maybe an exception, but this doesn't show up. Okay. What did this do? So it's creating a string, 267.exe, creates a connection to the internet, lists a bunch of URLs, and then for each URL, it tries to connect to that website and tries to download a file with that file name with 267.exe. And then it checks to see if the length of the file is right. And if it is, it runs the file. So there we go. It's actually trying to run a file on us. The file is called 267.exe. So there we go. We have figured out what that PowerShell command was doing. It was connecting to a bunch of websites and trying to download a file. Well done. You have now analyzed your first piece of malware ever. I hope that was really satisfying. Let's go back. The Windows Registry, I'll come back to that. So we looked at Process Hacker, Process Monitor. We played with some of the code. Right, and then I'll show you this. So again, I said that if we were connected to a network connection, we could analyze some of the web traffic that it generated. We're not generating any web traffic, but here's a program called Fiddler, sort of like Wireshark. It would have captured some of the web traffic that this macro ran, and we can see here, those should look familiar to you. Those are those websites that we just found in the code. So that file was actually trying to connect to those websites and was trying to download 267.exe. So yeah, that's sample one. It's a document with a macro, uses VBA. It is packed, we learned that. It downloads 267.exe and executes it. So the intelligence that we gathered by doing this exercise, we gained a whole bunch of IP addresses and web addresses of malicious websites. We have a process name to look out for, so 267.exe. We would immediately want to start looking to see if that has ever run on our computer, maybe to see if it's running right now. And we also have hashes to block and scan for. On Virustotal, it also told us some other names for that Microsoft Word file, so we'd want to look for those as well. But that's essentially what we've done. We've done a little bit of intelligence work and a little bit of malware reversing or malware analysis to figure out what sample one does. So now that we've done sample one, we're going to try sample two. But before we do that, we are going to reset the state of our machine. So go ahead and close everything that's on there right now and shut down your compute, shut down your virtual machine. So virtual machine is shut down for me. I'll give you guys a second. You then go back into VirtualBox. And now we're going to use that snapshot. You're going to see why this is so useful and so powerful. So again, we click on those three lines and three boxes to get this menu. We go to snapshots. And now you should see something that looks like this. So we have our current state. It says that it's changed. It means that it's changed from that clean state up there. I'm going to click on the clean state. So make sure clean state is selected. And then I'm going to click on restore. And it says you are about to restore a snapshot clean state. It says you can create snapshots of the current state by checking the box below. If you do not, then the current state will be permanently lost. Do you wish to proceed? I'm going to unclick that box. We don't want to make a snapshot of right now of what it's like with the document malware on it. We don't really care about that anymore. We've done our work. So uncheck this box for create a snapshot of the current machine, and then click on restore. So we're going to restore back to that first initial state. It goes really quick, and there we are now back to our clean machine when we started the workshop. You can see over here it should say the name of whatever your snapshot was called. So great, we're going to start this back up. I double click on it to get it started again. And now we boot up Windows 7. One more time. Glorious. While that's happening, I'm going to tell you a little bit about the Windows Registry. So I had it back here. The Windows Registry is something that's really important to understand when trying to administer Windows systems and understand what malware does. It's just really important for understanding Windows altogether. So what is it? You've probably seen it or heard of it before. The Windows Registry is just a database. So it's a program that stores a bunch of information in it. What sort of information does it store? It stores information that Windows needs. It stores information that other programs need, and it stores information about multiple users that use Windows. So if you were to write a program in first year, you may have written a program like a little computer game. I wrote a computer game like Candy Crush in first year. It saved people's high scores, and it just saved them into a file, into like a text file. When I loaded the program, it would just load the high scores out of the text file. We all know that that's not very safe because anyone could just go edit the text file and put their name in on the high scores, right? Right. It turns out Windows used to originally work something like that. Windows would save all of the data that it needed in these files called .ini files, and they would be scattered all around the machine, and it would just open them up, load the data out of them that it needed for running things. It meant that anyone could sort of go in there and change those. And you can imagine for a program like Windows, if some of those files start getting changed or deleted or moved and they're not there, things can break down really easily. So Windows built the Windows Registry, this database. Here's a picture of it. These are all sorts of files. It's in a hierarchy. And then on the right side, it shows you what's in the data that's being held in those registry files. So again, Windows uses this to store data that it needs. So like when it's starting up or about the programs or hardware that it needs. Other programs are allowed to use the registry. So if you install a game or like Microsoft Word, it's allowed to put things in the registry for itself and for Windows to use. And it can also store things for multiple users. So if you're using the computer and you change something important on the computer, another user can log on and they will also have that change because they use the same database. They use the same registry. So the registry is really important for understanding how programs and Windows all work together. We're going to see how changes get made there. So back to sample 2, your machine should be booted back up. Go back into your virtual machine, wherever it may be. Where's mine? It says it's running. There it is. So it's up and running again. And you should notice that your document file is gone from the desktop. That's because you've reverted back to your clean state. And we're back to a nice clean version of this. So let's go get that sample 2. So again, desktop, a folder called samples, sample2.zip. We're going to drag that out. It wants the password. Again, the password is infected. Click on OK. And close all of those. So there we go. There's some sort of infected file. It's on our desktop. We don't know anything about this. We're not going to run PE Studio just yet. We're going to drag it onto HXD. So HXD is our hex viewer. There we go. We're going to get all kinds of hex data about our program. I'm going to give you a minute. Tell me what kind of file this is. You've got your hex bytes. You know how to search for magic bytes online. Remember, that was Gary Kessler's website. You should be able to search and find out exactly what kind of file this is. Toss it in chat when you get it. Or wait one awkward minute with me before I just tell you. Bam, someone got it. right quick. It's an executable. How do we know it's an executable? And also, thank you, what for responding and answering that. We know it's an executable because those first bytes, 4 delta, 4D, 5A, those are the magic bytes for an executable file. You see over here in the string for that, it looks like MZ. MZ is what marks an executable file. And I'm going to go back to file signatures for delta 5A. That gives us this down here. Shows us, it says it's an MZ, and then it says Windows DOS executable file. MZ, you're going to remember this. It says, note down here, MZ are the initials of Mark Zipkowski, designer of the DOS executable file format. So to mark the DOS executable file format, he used his own initials. So now you know, if you ever see MZ at the beginning of the file header, that's going to be an executable file. Cool thing that guy did, immortalized himself in code. So let's just close that. So now we know that we've got an executable file. Let's drag it over PE Studio again. Now, PE Studio is going to take a little while longer to run this. You can see over on the left here, it says wait on a bunch of these things. That's because it's analyzing this file. While it's doing this, I'm going to jump back to my PowerPoint. There we go. We did our hex editor. We saw what was going on in there. So PE Studio, the first time we ran it, looked like this. PE Studio this time when we run it is looking like this. It's giving us a ton more information. So I am going to take you on a quick tour of what we're looking at here. To start out, we have our old friends, the 3 hashes. If you wanted, we could go to Virustotal and do a search on this. We're running way longer than I expected, so we're not going to do that. We're going to skip that. Here are the first bytes of our file again. There's our MZ. File size, our good friend entropy. Is this file packed? Yes or no? And the answer is, of course, yes. Remember, on that scale of 1 to 8, 6 was obfuscated. This is just about a 6, so there's probably some packing that's going on here. Imp Hash, I'll come back to that and explain that after. Signature is Microsoft Visual C++ 8. So that might tell us something about how it was made or how it was packed. Entry point tells us where it starts the program. Interestingly, it tells us right here it's an executable. It is a 32-bit architecture that it was built in. Then there's these compiler stamps and debugger stamps. So these tell us about when the program was compiled. These things could be faked. So it's not always true, but it says it was compiled on Sunday, October 6th of 2019 at 11:38. So that's interesting. Let's go to indicators. We looked at this before. So there's more information in here now. There's way more stuff because this is an executable. I'm just going to point out some things that are a little bit interesting here. It says this file references debug symbols. And then we drag this over. And it references this mtim.pdb file. .pdb is I think a program database. So this is the debug information for the program. Like when we compile C programs in Linux or Windows, if you've done it and you add the TAC-G flag so you can run it in GDB with all of the information inside to make it easier to debug, someone did that with this program. So they were debugging this program at some point. 2 entries up here, we see the original name of this file has been found. The name was emitim.exe, so it originally had a different name. That's interesting. That's a piece of intelligence that we can learn about. Let's go down. Directories, not interesting. Sections. So sections is an interesting place. This is going to tell us about different areas in the code. So we can see the .text, .data section. If you've done Computer Science 355, you should know about those areas in memory and what they hold. Interestingly, it'll show us the entropy of each of those sections, and it'll show us an MD5 hash of each of those sections. This is because you can change pieces of code and leave other pieces the same. So we could search for the hashes of different areas of code to see if it's related to other malware. Maybe it uses some of the same code, or maybe it's just an altered form of another piece of malware. So we could use those hashes to figure that out. The entropy is not the same in all of these. In fact, it's really different. The next thing, file ratio, tells us that 60% of this file is held in the .text section, whereas only 2% is in the .data section. That's kind of weird. The .text and .data section is where a lot of stuff should be held, but I think most of it would usually be held in the .data section. It's showing that the entropy in .text is almost 6, whereas it's only 3 in the .data section. This is best guess that the packer has packed all of the code into the .text section. Usually it would be in .data, so it packed it all into .text, and when it runs, it's going to move it. It's going to unpack it into the .data section and then run it. The next thing we're going to look at, libraries. So these are the libraries where it's pulling functions in for the code. In the same way that we would import in our programs, this program is doing something similar. So it's pulling things in from kernel 32, user 32, and GDI 32. We'll go down to imports, the imports button over here. And this is a treasure trove. So for doing static analysis, this can tell us all kinds of stuff. These are the functions and the APIs that are being imported by this program when it runs. We could go through here to try to figure out, without running the program, we could just try to figure out some of the stuff it's trying to do. And there are some of these that are sort of telltales for things that malware would want to do. Things like finding processes, things like creating new files, things like getting strings or getting the usernames. So it's getting environment strings. It's calling exit process here, so it's exiting a process. It's getting threads. This program is sort of looking at what's happening around it and trying to figure out what it's going to do. I could go through, we could do a whole bunch of stuff on just imports and what they are and which ones are interesting, but we're not going to. Just important to know that this would be a real good place to start looking for what this program was doing. Exports, it's exporting something called run. So it's exporting something. Someone says, I'm guessing begin paint doesn't open paint to draw me a nice picture. No, probably not. Probably no picture. I'm not sure what begin paint does. I'd be curious to know. So exports, it exports something called run. There's also a bunch of strings here, our good friend strings. Let's organize the strings by size. The biggest size here is 500. Remember before it was like 5,000 and it said, that's really suspicious. This one's only 500. We scroll down and there's all kinds of 500 length strings. This is probably some packed obfuscated code in here. I would guess that that's what it is. We could search down here and we could also try to find, we can see here some of our functions that we saw. We could look through here for clues about what the program might be doing. We could try to see if it has any names inside of it, any clues that were left behind by the people that wrote it. Maybe some web addresses or IP addresses that would be useful for us if we're trying to defend against whatever this is, but we don't see them here. So let's go ahead and close let's go back. Sorry, I said I was going to go back to the first screen, first thing listed at the top here, Imp Hash. I'm just going to explain this. Imp is import, so this is a hash of the import table. All of these imports that we saw down here, they're all stored in a table, and this is the hash of that table. So again, if this is some new form of an old piece of malware, it might change the code, but it might keep all of the same imports. And we could just search the import hash to see if it's related to other pieces of malware. This way we can find if it's just a new version of an older piece of malware. Maybe they didn't change anything. So maybe it's a cousin or a descendant of some other piece of malware. That's what Imp hash is good for. So yeah, hashes, again, are awesome. So yeah, let's go ahead and close PE Studio. So we're going to do the same thing we did before. We're going to right-click Process Hacker, run as administrator. Yes, so Process Hacker is now running on our machine. Double-click Procmon, open Procmon. This time, instead of unchecking the green thing, we're just going to leave it checked. So these are filters. Before we saw everything that was running on the computer while Procmon was capturing. This is a filter that I've created. So it says operation is process create include. What this is going to do is it's only going to show us processes that only things that are related to processes that have started since we start the capture. So it's not going to fill in 100,000 things. It's only going to show us the processes. So just click OK here. So it's now capturing events. We can see that down here. We're going to go ahead and run our malware. Yeah, we're going to go ahead and run our malware. So this file, if you double click on it, it's just going to ask you what kind of file it is, and it doesn't know how to run it. We know it's an executable, so we're going to rename it. So I right click on it, rename, just go to the end and change that to .exe. And now when I click out, you're going to see this is changed to an executable file. So now go ahead and run that executable. You'll see down in Process Hacker, stuff is happening. If you scroll to the bottom, you should see your process down there. Process Monitor, things are popping up. If you're paying close attention, you should have noticed something very suspicious happen on the desktop. And in Process Hacker, your process seems to have disappeared. And now new things are going to start popping up down at the bottom on your list, and they're going to start disappearing. Does anyone notice the really strange thing that happened on the desktop? Toss it in chat if you do. Okay, this should have run long enough now, so we're going to stop the trace. So Process Monitor over here, go to File, Capture Events, so we're going to stop the capture. Now you should notice it's not ticking up down at the bottom here. Yeah, someone's paying attention. They said my guy just disappeared. You should have noticed that .exe file that we had on the desktop. It's gone. It's disappeared. That's a little bit weird. Yeah, exactly. That's the exact reaction you should have. So yeah, we've run our program and it's disappeared itself from the desktop, and a bunch of things are running. So we can scroll up here and sort of see what's happened. It's not a lot of clues as to what went on. There's a new process down at the bottom here called class vcs.exe. We see it over here as well. It's actually listed right after our program that ran. There's our .exe file. There's another one with the same name, and there's a class VCS, and then a bunch of SVC hosts. You should notice down here, I know Abner said that things were flashing red and they were concerning. DLL host.exe keeps popping up. It runs for a while, it turns red, and then it disappears. So we're kind of curious, what is this thing that's now running? So let's go ahead and right click on it. The class, so is it class vcs.exe? Right click on it and go to properties. Here we get all kinds of information. We want to learn something about its memory, so we can click on memory. This will start showing us the memory for this process. You should see up here, strings, our old friend strings. Let's click on that. It wants us to find minimum length of strings is 10. Okay, let's just find strings of length 10 or more in this process. Now we can make this window bigger. This is all the stuff being held in this process's memory for strings. And scrolling down, we see all kinds of IP addresses, or what look like they could be IP addresses. There's files and folder names here. There's all kinds of really interesting stuff. We could actually filter this. It'll use a regex. We could go to CyberChef, steal our regex for IPv4 IP addresses. Actually, I'm going to do that quick. You don't have to do this. So enter the file pattern. I don't know off the top of my head the file pattern for IP addresses. So I'm just going to search regular expressions, pull them in, user defined, IPv4. There we go. That big long jargle there, that's a regex for finding IPv4 addresses. Just paste it in, click OK, bam, there we go. Some IP addresses. Great, there's some IP addresses. Those are probably not great. What's this? I don't know what that is, but it's probably not good. So that's a way that we can go through and we can see all of the strings that are being held in this process right now. I'm going to go ahead and close all of this. So that was just sort of a demo of what that's doing. Yeah, so now we're going to, oops, sorry. We want to know more about these processes that are running. Specifically this class VCS. We also want to know what happened to our one that we started, the olqxjben.exe. First thing I want you to do is to right click on the column headers up here and click select column. This shows you which columns you want to show. Go down here and click thread ID. It's in this bottom box, sort of the bottom right under process ID, and click OK. That's just going to add the thread IDs so that the threads are each process that's running. They get an ID by thread. That just adds that to this list. We're also going to remove a filter. So we want everything, not just the processes that were running since we started. So again, in our toolbar up here, there's sort of one that looks like a diamond with a little blue thing on it. It says filter. Click on that. We get this box again. This is the same box that we had when we started. This operation is process create, that custom rule that we created. Uncheck that and click apply. And we should get everything now listed. So we're going to take that filter off, and now there's just everything that's in here. You should notice now we talked about registry keys. There's registry keys listed. So these are registry keys that are being accessed and changed by every process on the computer. But now there's way too much stuff here. This probably all isn't our process. So we're going to go File. We're going to save all of this output now. So File, Save. We want to look at where we're going to save it. Again, if I'm going too fast, let me know. Alex is also in the chat, in the Discord chat, if you fall behind. So format, we want comma separated values. So we want a CSV file. And then we're going to change the place where the file is saved. So down here at the bottom, just click on those three dots. And we're going to just toss it on the desktop. So just click on desktop here, file name, logfile.csv, save. And OK. Now our log file is on the desktop. So that's just a file that contains all of this information. Well, what good is that? We want to analyze it, and we're going to use proc.dot to do that. So open up proc.dot. It's on your desktop, the big red dot. Give you a second to sort of catch up. Take some water. So proc.dot is now opened. Now we're going to open, over here. It says monitoring logs, and then it says procmon. That's our process monitor program. So click on the three dots. Then go to your desktop and select the log file. So click on desktop, log file. So now we're just loading in our log file into here from procmon, the one that we just saved. Next thing we do is we go over this box here, render configuration. It says launcher. We go and click the three dots next to the launcher box. Now it's going to analyze that procmon file. So it's going to look at everything in there. It's going to look at all the processes that it found that were running, and it shows us the ones that we want. We want the process that we started with, so the olqxjben.exe. So double click on that, the first one that's listed. So we're going to select that process, and then you can click refresh over here. So we want to refresh the view based on that one process, and proc.dot is now building a graph of what this program did. So I'm going to maximize this. You can click and drag to move it around, and hold Control on your keyboard and scroll to scroll in and out on it. I'm going to give you a minute to look this over. Emily says, can you actually go over the export again? So again, in process monitor over here, you remove. First thing you need to do is add the process ID. So right click on one of the columns over here, select columns, thread ID, then the filter. So remove that filter, then file, save. Save it as a CSV file and save it on your desktop. So I'm not going to save it. Sorry, back to proc.dot. So yeah, look around this graph and see if you can figure out what's going on. So zoom in and you should see all sorts of interesting information about what's going on. I'm going to give you 1 minute. Mine has disappeared for some reason. And again, just toss into chat whatever you find interesting or what it is you find. Okay, anyone any closer to understanding what this process did or what happened? I'm going to walk you through. So this is a graph of the process running and everything that it did. It started here. It created a thread. That thread created another process with the same name, but notice it's all in lowercase. It says that it's going to be based on that file that was on the desktop. But notice this thread then said kill own process. So this thing started up, started another copy of itself, and then closed itself. It shut itself down. This copy then created another thread. It renamed from the file on the desktop that we had, and it renamed itself over here to C users, IE user, that's us, the user, app data, local, class VCS, and then class VCS.exe. So it's renamed itself and moved itself. And I just went into the file explorer, and sure enough, if you go to that location, here's that file. That's the one that was on the desktop. It didn't get deleted. It actually just got moved. So it moved itself somewhere on the computer. So it then created another process with this name, class VCS.exe, which creates another copy of itself and kills itself. And then this copy has a thread which is now doing all of this. So it's reading these things. These are the registry keys we were looking at, and it's creating new registry keys. Why is it doing that? It's probably doing that to create copies of itself, to become persistent. So what it's doing is it's probably going into the registry and saying, start me up with the computer. So that if you shut down your machine and start it back up, this process is still going to run in the background. And we can't see it here, but let me go back to the PowerPoint. I believe I have a snapshot of it. No, I didn't. If we were doing network analysis or tracing the network traffic, we would have been able to see that this was also trying to communicate with a server outside in the outside world. It's probably trying to communicate either information from this machine out, or it's probably looking for instructions from somewhere out on the internet. The thing that it's sending information to or trying to receive information from is known as the command and control program. So it's probably a server out there that's waiting for all of these programs on different computers to phone home, essentially saying, I'm on this computer, here's what kind of computer it is, here's the information I have, and then just waiting for information on what to do. But this is what it looks like when this process runs. It moves itself around and it creates registry keys registry entries to try to keep itself persistent or alive on the computer when it runs. So again, this has been process 2. We're running really short on time, but there's something really interesting in the next sample. It's very similar to this, but we're gonna jump and do the next sample. So let's close this. We could save this if we wanted to, send it out, but there you go. You've got more intelligence. Let's close everything and shut down our machine. Everyone still following along? Anyone really lost? Everyone having a good time? And this is what manual analysis looks like. So static analysis and then dynamic analysis, running it and seeing what it does. So yeah, that was process 2. So what we learned, it was an executable, it was packed, copies itself, creates registry entries, establishes persistence, and it tries to communicate with the net. We would learn that if we had a network connection. Again, our intelligence, we got IP addresses, malicious sites, processes, names to look out for, and hashes to block or scan for. So awesome. I don't know why that time to play screen was there. Sample 3. So we're going to go back to VirtualBox. Let's restore the clean state. So go back in your snapshot, find your clean state, click restore, go back to before this malware was on there. Again, click this box on the pop-up. We don't want to create a snapshot of our current machine, the one with malware on it. We just want to restore back to the clean one. So we restore back to clean and we run again. And once again, we load up Windows 7. So this time we're going to do pretty much the same thing that we just did. We're going to open up Process Hacker in administrative mode and Procmon, but we're going to use a slate. We're going to add a program in here called regshot. So wait for this to load up. Again, activate me later. Okay. Here we are. We're back on the desktop. So I'm going to take sample 3 out. So samples, sample3.zip. Copy this file out. Password is again infected. The word infected. So there's our file. We've copied it out. Close all of these. Again, you could run it in HXD. When we look at it, it starts out with 4D 5A. There's our MZ, our good friend, the immortal himself. So we know that this is another executable file. We look at it in PE Studio. We're going to do this one really quickly. PE Studio is analyzing stuff. Again, we have all of our hashes. Remember, those are really important. We could go search those on Virustotal. You would find more in interesting stuff. The signature is different. Microsoft Visual C#. It's an executable. It again is 32-bit. It was compiled February 21st of 2015. This is old. If that stamp is right, then this is pretty old. Some indicators, directories, sections, strings, all kinds of strings. Let's see what the biggest strings are in here. 287 bytes for the biggest string. This is way smaller than before. And what is that? Something padding? Yeah, that's interesting. Don't know what that is. These could be base 64, although it doesn't seem, PE Studio doesn't seem to think so. So that's just a poke around there. The thing we should have noted, of course, was entropy, 6.391, almost definitely packed. So we can't just toss this into Cutter or Ghidra or reverse program and just see what's in there. Okay, so again, Process Hacker. Let's run as administrator. Yes, so right-click Process Hacker 2, run as administrator. Here it is. Going to run Procmon again. Yes, run Procmon. We're going to say OK here. We're going to run it with our filter on. So process monitor is running. We can see the processes being logged down here in the bottom left. And this is where I said we're going to do it a little differently. So open up RegShot here. And RegShot is a program that's going to take a snapshot of our machine. It's going to take a snapshot of the registry specifically on our machine, and then it's going to compare it to another snapshot we're going to take later. So here it says compare logs, save as. We're going to save it as a plain text, but then click on the first shot button. This pop-up comes up, and then we're just going to say shot. So you can see in the bottom, it's looking through all the registry keys and values, and it's storing them all. And there, when it's done, the second shot button lights up, but we don't want to click on that yet. So there we go. We've taken a shot of the computer. Now our malware, our synapse file over here, right-click on it. We're going to rename it. So from .bin to .exe. Yes, I want to change that. It's now a .exe file. It gets a fancy-looking picture. Just make sure. Was there anything else? Nope, that's everything I wanted to do. All right, double-click on it and run it. Do you really want to run this program? Yep, we sure do. Look at that. That's fun. Little error pop-up. Okay. Look in our process monitor, and it's running down here. So it's doing its thing. We're seeing some stuff being created, some stuff being killed in our process hacker. But our malware is certainly running at this point. At this point, let's take a second snapshot now. So in RegShot, put it back up, second shot and shot. So it's going to take a second snapshot of the computer. And it's now going to compare these two entries and find what's different between them. So we've got our second shot, and I'm going to click compare. It's now running them. It generates this file for us. So here's everything that seems to have changed between these two snapshots. So a bunch of keys were added. Some of these are actually going to be genuine and honest-to-God programs that we're running on this computer. Some of them are not. AGP subsystem. Oh no! Someone got the blue screen of death. Classic. I'm sorry about that. I didn't think that would happen. Happy that didn't happen to me. Yep, you can restart. You can also follow along on this video when it goes online. AGP subsystem task. That one could be interesting. There's some .bins here. We're seeing AGP subsystems again. C program files, AGP subsystem. So there's probably something that's been put on this computer. We're seeing that all over the place, and then a bunch of these are really long. If we go to C, we're almost at 8 o'clock. This is just going to be a little bit longer. I'm actually just going to finish this. So C, is it program files, AGP subsystem? Yeah, there's a new file there with that same icon that we saw before. Interesting. This is probably its persistence location. So this is probably where it's copying itself over to. So go ahead and close RegShot. Before we do anything else, go to your start menu, go to Notepad, run Notepad, and let's pretend we're logging into our banking website. So fancy banker, fancy banker 1986 exclamation point is my username. My password, of course, is super secret. It's SolarWinds123. There we go. This is, let's pretend, our website that we're going to log into banking. We've done that. Now let's close it. Do you want to save changes? Don't save. So we pretended we logged into our bank. Now we're going to do the same export on Process Monitor. So let's go to File, down to Capture Events. We're going to stop the capture. I have captured 2.5 million events on Process Monitor. That's a lot. So again, before we export to ProcDot, right-click, select Columns, Thread ID. So we've got all of our thread IDs now added in the data. We also want to shut the filter off here. So take that filter out, that first one, like we did before. It's getting annoyed, or it's going to take a while because there's 2.5 million events. So there we go. It's showing all of these events. Now I go to File, Save. Again, when I save, I want to save it as a CSV file, and I'm going to add it to the desktop and save it there. Okay. Again, a lot of entries because we ran this for a long time. Oh dear God, I ran it for too long. I shouldn't have run it for this long. It's going to take 10 minutes to save. I'm so sorry. I don't think I ran it this long when we tested it. All right, I'm going to cancel this. I'm going to cancel this. If you guys have it at not 2.5 million events, and you get to save that, you can run it in proc.dot. Yeah, I feel bad. The only way for me to sort of get back around this would be, well, actually, I think I can. I'm going to kill this. Don't follow me right now. I'm going to terminate the malware. I'm going to exit. Let me see if I can save this. Process monitor. Okay. Run malware again, get the error. Malware is running. Notepad. Fancy banker. SolarWinds 123. Close, don't save, and we're going to stop the capture. No more capturing events. Let me see if this is going to work. I'm not 100% if this is going to work. Save it as a CSV to the desktop. Okay. Doesn't take me 10 minutes, and now proc.dot it. I'm not 100% if this is going to have worked this time, because it might have already had everything in there. So we're going to open up the log file in proc.dot again. Over here, launcher. So it's going to analyze the file. I mean, if I would have waited before, it probably would have taken a hot minute for it to analyze the file. I want it to analyze the first instance, synapx. synapx.exe. This might not work. It might. So there's our graph. I don't think this is going to be the same as yours if you did it the way that I did it. But here's a graph showing us everything that it's created. So here's a registry key that it's done something with. Here's that program file, agpss.exe. And it's showing us some folders, some files here. C users, iuser, appdata, local temp. There are temp files that are being created by threads. Task.dat, app roaming data, local app. I'm going to try this first one. So C users, let's try to navigate to this folder. C, nope, this is my personal computer, not this one. There we go. C, users, IE user, app data here. I've enabled the hidden folders, hidden files and folders for you to see. So app data, roaming, 7901. Okay, here's AGP subsystem again. All right, let's minimize our programs in the background. Let's take a look at what's in these files. So run.dat, we're going to toss that into HXD. Nothing. That doesn't look like anything. That's no good. Task.dat, let's open up that. C users, iusers desktop, synapsx.exe. So that's something about the file on the desktop. Logs. What's that? That's got to be great. Logs. IE user. That's our username. There's 2 files in here. I bet you I know what those are. So what is this? Explorer, Start Menu, Notepad, Untitled, Not Fancy Banker 123, 1986, and SolarWinds 123. And what's in this one? Untitled, Fancy Banker, SolarWinds 123. Oh my god. We've been keylogged. So that's what these files are. This program is keylogging. It seems to be saving data to other places. So yeah, that's not good. This is really bad. This program is a keylogger. I also guarantee you that if we were doing network analysis, this program would be trying to connect to, I'm going to close all of this now, this program would be trying to connect to the internet, where it would be trying to export all of this stuff. And the reason I said that we run into our bank, or we're logging into our bank, is because this is a Trojan that is specifically built to steal banking software or banking information. It's the Banking Trojan Emotet, which has been running since the mid-2010s. It's like 2014, maybe 2013 it started. It was actually just disrupted and in part taken down in January, I believe, in the Ukraine. They arrested a bunch of people and really disrupted the command and control servers. Last thing, really quick, auto runs. You can run this. Auto runs takes a look at the system and tries to see, looks at the registry keys and tries to find stuff that is set to run. You can see a task scheduler down here. The AGP subsystem is running some sort of scheduled task on the computer. An AGP subsystem up here is also in the current version run. I believe that's going to be where it's telling the computer to run that program on startup. So that's it gaining persistence. Auto runs is just, there's, as you can see, tons of stuff in here, but this is a way to see what is running on your computer and when you're setting everything up, or sorry, when you're starting things up. So that's auto runs. So again, we're going to shut down. That's our 3 samples. So we're largely finished. Time to play. We've played. Yeah, if you were running proc.dot with network stuff, this is what it would look like. There's your graph, but you would have also seen this right here, showing you that there was a UDP packet or UDP request that was sent to this domain. That I think is a Google backup server, but this is Synapse X this Trojan, this banking software, just checking to see if it has an internet connection on startup to try to see if it can connect to the net. That's what it would look like if we had a network connection enabled. This is why I shut it off, is I don't want it doing this to you. So sample 3, again, executable, copies itself, registry entries, keylogger, and it communicates with the net. Again, you've got lots of intelligence, so you could toss this into your firewall rules. You could go looking around on computers in your system, making sure it doesn't have any of these processes. So again, we've gone over CyberChef, Virustotal, PE Studio, Process Hacker, and Process Monitor, proc.dot, HXD, and auto runs. A whole bunch of programs that you've learned the very basics of. You've learned the very basics of static file analysis and some tools to do dynamic analysis on a VM, where it's safe for you to run these things and see what they do. So we just traced through and saw what this virus, this malware does. If you are interested in learning more, I cannot recommend enough this book, Practical Malware Analysis. It's really, it has a really great reputation. It is really well written. I am about halfway through it. It is really awesome, and there's so much more to learn. And the book is really good about being really direct, and it gives you hands-on stuff. I need to acknowledge OX Fox, his YouTube channel. He did everything you did here was basically stuff that he did in walkthroughs on his YouTube channel. I essentially stole a lot of this. He's got a sort of 10 video series on malware analysis. You can go there and you can find out more stuff that you can do. He basically went through all of these samples. Otherwise, that's everything for tonight. Thanks everyone for coming. Sorry we went a little bit over time. We're going to be doing some more malware analysis next week, but I'm going to be showing you some of the more automated tools. This is the very manual way of doing this. There is stuff that is built that will run all of this stuff for you and just spit out a report. So we're going to be looking at some of that, and I think we're going to be looking at Yara for analyzing files and file analysis. So yep, good luck with end of the semester. I know we've got 1 month left. Reminder that the club AGM is in 1 month. For elections and constitution amendments. If you have any questions about that, just let us know. Otherwise, have a great night, everyone. Thanks for staying a little bit longer with us, and have a good night. We'll see you all next week for another fun thing of malware analysis. Sorry, I was just checking messages to make sure I didn't miss anything. Yep, have a great night, everyone. Thanks.